this video I'm going to be working on an individual derivative. It is going to be a trig derivative with multiple chain rules. Alright, and I do have a couple of derivatives up here that you are going to need to have these derivatives memorized to be able to do this particular derivative. Alright, now if I can recognize that I've got some composite functions, a function inside a function, then it's going to be easier for me to recognize where my chains are going to occur. Right here, that little 2 right there, alright, it's telling me I've got 2 of these functions right here. I generally have my students pull it out so that they can clearly see that something is being squared there. So before I start the derivative, I rewrite that original problem as 2 secant cotangent of 3x to the 5th, and then that entire thing squared. What that does is that allows you to see, oh, I have an inside function right here. I also have something being raised to that second power, so I've got the outside function, so that's going to be where my first chain is. Alright, I'm going to come all the way over here because I think this is going to get kind of long. We're going to now take our derivative, so f prime of x. Okay, so this something being raised to the second power is my outside function. We take the derivative of the outside function, we leave the inside function alone, and then we multiply by the derivative of that inside. So when I pull that down in front, I'm going to have 2 times 2, which is going to be 4. I am going to leave the inside function alone, so secant cotangent 3x to the 5th. Alright, remember to subtract 1 from that exponent, so 2 becomes a 1 there, so we'll go ahead and put the 1 there just so we can see it there. Now, times the derivative of the inside. I'm going to use ddx notation so I don't drop any chains. So now I'm going to have ddx of secant cotangent 3x to the 5th. Okay, now I'm going to keep everything here the same. In the next line, I'm going to go ahead and do the derivative there. So I will have a 4 secant cotangent 3x to the 5th. I am going to drop the to the first power. We don't need that anymore. Alright, now here, again, hopefully you can see that secant is the outside function and the inside function is everything here. So we take the derivative of the outside function, we leave the inside function alone, and then multiply by the derivative of that inside function. So derivative of secant is going to be secant tangent. So I'm going to have a secant cotangent 3x to the 5th, and then tangent of cotangent of 3x to the 5th. Alright, now I left the inside alone on all of those. Cotangent 3x to the 5th, cotangent 3x to the 5th. Now I'm going to multiply by the derivative of the inside, so there's my chain. So ddx of cotangent 3x to the 5th. Okay, now all of this again is going to remain the same, and I'm going to take the derivative here, and again you've got an outside function and an inside function, so I'm going to have one more chain. Alright, I probably am going to move this a little bit over to the left because I'm going to run out of room here, so let's come all the way over here. So let's have a 4, we'll have our secant, and then cotangent 3x to the 5th, and then secant cotangent 3x to the 5th, tangent cotangent 3x to the 5th. Alright, now derivative of the outside, leave the inside alone, multiply by the chain. Derivative of cotangent is negative cosecant squared, so negative cosecant squared, leave the inside alone, 3x to the 5th, times the derivative of that 3x to the 5th. Okay, so again, let's write out that whole entire line right there. So we will have 4, I'm going to take away those big brackets, secant cotangent 3x to the 5th times a secant cotangent 3x to the 5th, tangent cotangent 3x to the 5th times the negative cosecant squared 3x to the 5th. Alright, now, find the part that changes here. We're going to do the derivative of our last thing. No more chains. This is just a straight polynomial function there, so derivative there is going to be a 15x to the fourth. Okay, now at this point, I need to go through and see if I can combine some like terms, see if I can put anything together here. Alright, I've got a secant cotangent 3x to the fifth right here. I have a secant cotangent 3x to the fifth right here. Alright, yes, it is being multiplied there by that tangent and that negative cosecant. Alright, I've got two of these terms, so I can write this to the second power. Alright, in the same line, let's go ahead and also I've put together my coefficient I can pull out in front. I've got a 15x to the fourth right there. I've got a negative right there, and I've got a 4 right there. I can multiply those three things and pull them out in front as well. So that'll be a negative 60. So negative 60x to the fourth. Alright, I'm going to put these two together and write it as to the second power. So I'm going to have a secant squared of cotangent 3x to the fifth. Alright, I still have my tangent term, so tangent of cotangent of 3x to the fifth, and I still have my cosecant squared of 3x to the fifth. Alright, I can no longer put anything else together. Alright, very long answer there as my derivative. Okay, so keeping straight of all the chains. Alright, there were lots of chain rules in this over and over and over. Alright, using this ddx notation really helps you to keep track of your chain. The main thing is, like, let's just go back over this one here. Alright, my outside function was secant, my inside function was cotangent 3x to the fifth. You take the derivative of the outside function and leave the inside function alone. So secant, leave it alone, tangent, leave it alone, because derivative of secant is secant tangent. Alright, then multiply by the derivative of that inside function. And again, using that ddx notation allows you then to just stop and look at this and see, oh, I've got another outside function, inside function. Very, very important when you're doing multiple chains like this, not to drop anything, to use that ddx notation. Definitely thanks for watching. If the videos are helping, please be sure and share with your friends so that they can benefit too. And don't forget to subscribe to the channel. Thanks.